Matter is anything that has a mass and is known to occupy a particular volume. A matter can actually exist in four different forms: solids, liquid, gas, which are the most prominent forms, and we also have plasma as the fourth state of matter, but these three are the most prominent, and each of these have their own properties. All of them have their own distinct properties. The arrangement and movement of particles, which are either atoms or molecules, will determine whether it is a solid, a liquid, or a gas. Now we can understand each of this phase using the example of water. Now water can exist in all the three states: a solid, a liquid, and a gas. We all know that the solid phase of water is called ice. The ice cubes that we see in refrigerator is actually example of solid water. Now in a solid there are very strong intermolecular forces of attraction between the particles. Now in the case of ice there are very strong intermolecular forces of attraction between the water molecules. In all the solids, the particles are so closely packed together and they hardly have any space to move. This is because of the strong forces of attraction that hold them together. So, this is the reason solids have a definite shape and volume. This property also makes the solids very difficult to compress into a smaller volume. So if we heat a solid or if we give some amount of heat, then the particles will start to vibrate faster and faster. So the energy that has been provided will cause the particles to vibrate, and this will weaken the intermolecular forces of attraction between the water molecules. So more and more heat is going to disrupt the forces holding them together and reaches a point where the molecules can now start moving freely. The solid will now start to melt, and then it goes into the next phase, which is called the liquid. So the temperature at which a solid melts and transitions to the liquid phase is considered its melting point. Moving to the next phase, which is liquid. So the water that we drink every day is actually in the liquid phase. In the liquids, the molecules are arranged in small clusters. They are in small clusters, but they have the freedom to move around each other. They have the freedom to move around one another. So liquids have a definite volume, but they don't have a distinct shape. They would rather just assume the shape of the container that they are put in. They can easily move from one place to the other as they don't have a specific shape. Again, if we heat a liquid or if we provide energy to liquids, then the particles, the individual particles will gain more energy and the clusters will start to break apart. So heating a liquid will actually transition it to the next phase, which is called the gaseous phase. So the molecules, individual molecules, by gaining more energy, now move apart from one another and they will start moving more rapidly. So this is actually called the boiling point. So boiling point is the temperature at which a liquid transitions to the gaseous phase. It's important to note that liquids occupy a definite volume, but they don't have a distinct shape. Next phase is the gaseous phase or the gas phase. Here, the molecules are moving very rapidly and don't keep a definite shape nor occupy a particular volume, as the intermolecular forces of attraction are very weak and the molecules are also very far apart from one another. So gases have neither a distinct shape nor occupy a defined volume. It's important to note that the particles in a gas are constantly colliding with each other and with the walls of the container, and this is because of the high energy associated with the molecules. So they're constantly bumping into one another or bump into the walls of the container. It is important to note that pure substances like water have a definite melting and boiling points. In the case of water, we know that water melts at 0 degree centigrade and water boils at 100 degree centigrade. So at 0 degree centigrade, you would see the transition from the solid to the liquid, while 100 degree centigrade is where you see water being transitioned from its liquid to the gaseous phase. Different substances have different melting and boiling temperatures. So to quickly summarize the essence of this video, so solids have a definite shape and occupy a definite volume, and the intermolecular forces of attraction between particles are really strong. So they are fixed in place and are in contact with one another. Coming to liquids, liquids have a definite volume, but they don't have a specific shape. The intermolecular forces of attraction are moderate and the molecules are in contact, but they're not fixed in a place. Coming to gases, gases neither have a definite shape nor occupy a definite volume, and the intermolecular forces of attraction are the weakest in gases. The particles are not in contact and they are just randomly distributed in the space. So if we see this figure, we can define each conversion of phase. As we can see, the change of particles from a solid to liquid is called melting, and the phase change from a liquid to a gas is called its boiling point or vaporization. Now, condensation is the process by which a gas gets converted back to its liquid form. For example, when water vapor comes in contact with a cooler surface, then the energy between the water molecules reduce, and this causes them to condense into a liquid again. Okay, so condensation is the opposite of evaporation. Further, we have something called freezing. So at 0 degree centigrade, the water molecules further lose their kinetic energy and slow down, allowing the intermolecular forces to draw them together to form a solid again, which is called ice. So, melting, boiling, condensation, and freezing. We also have two other terms, which is sublimation, wherein particles directly transition from a solid to the gaseous phase. Similarly, another important term is deposition, a process where molecules in gas phase directly move back into the solid phase. So it's important to know that temperature has a very important role to play in this whole process. And solid to liquid to gas is when you increase the temperature, while the reverse process takes place when there is a decrease in the temperature or the heat. Finally, we have the plasma, which can be considered as the fourth state of matter. Now, if we further increase the temperature of gases, then they can move to this state, which is called the plasma. So, at the very high heat given to gases, the atoms that are present will start to lose their electrons, creating a mixture of free electrons that have dissociated and a pool of positively charged ions. So, when a very high amount of heat or temperature is given to some of the gases, then the atoms that are present will lose their electrons, forming a sea of free electrons. Because free electrons are present, they have the ability to conduct electricity. They can conduct electricity. So some examples include lightning, fluorescent lights, and stars. So the stars that we see in the night are typically can be referred to as hot balls of plasma.